on behalf of the Center of Excellence in Disaster Mitigation and Management, IIT Roorkee. We also extend the greetings of International Day for Disaster Risk Reduction celebrated today. We have gathered here to witness the second Professor J. Krishna Memorial Lecture series being organized by the Center. A hearty welcome to one and all in the session. I'm Professor Harshit Sosin-Lakra, and I'm very delighted to be your host for this session along with my colleagues here. We are very privileged to have with us today Dr. Sailesh Nayak, Director, National Institute of Advanced Studies, Bangalore, former Secretary, Ministry of Earth Sciences, as the guest speaker. Welcome, sir. Welcome to the Institute. We are also blessed to have with us Professor and Director Ajit Chaturvedi, sir, IIT Roorkee. Welcome to you, sir, on this platform. Today's event is structured in the following manner for you, all of you participating. First, we will have Professor Sumit Sen, head of the center, who will share with us brief on the center and its activities. Thereafter, our respected Professor and Director Chaturvedi sir will extend brief remark on the endowed lecture series. Following that, Professor P.C. Ashwin Kumar will introduce our esteemed guest speakers of today, Dr. Sailesh Nayak. The lecture would be around 1 hour length, followed by a question and answer session moderated by Professor Ashwin Kumar. Before closing, we shall come together for a group picture to remember this day. The vote of thanks will be extended by Professor Anil Gauri Shetty, and he will be declaring the closing of the event today. Moving forward, I invite Professor Sumit Sen, head of the center, to brief us about its vision, strength, and activities. Over to you, sir.
Thank you, Professor Lakra, and good afternoon, everyone who all have joined us for this special event organized by Center of Excellence in Disaster Mitigation and Management, IIT Roorkee. To give you all a brief overview of the Center of Excellence in Disaster Mitigation and Management at IIT Roorkee is the first academic center on disaster mitigation and management in India, which was started in 2005. Professor D.K. Paul was the founder head of the center. Our mission of the center has been towards human resource development for disaster mitigation and management to protect the people, environment, and economy, and ensure a disaster resilient society through education, research, and development. This has been achieved by focusing on interdisciplinary research by cutting-edge research in science and engineering, as well as based on the 4 pillars of disaster management, that is preparedness, mitigation, response, and recovery. Our center started the multidisciplinary postgraduate program on disaster management and mitigation since 2012. We have MTech as well as the PhD program running from 2012. The center has joint faculty, around 17 joint faculty and 1 core faculty in the domains of earthquake, landslides, cyclones, pretty much all the natural hazards like floods and fire. Plus, along with it, we have industrial disaster, specifically focusing on chemical, biological, radiological, and nuclear hazards. Many of our research and projects have been funded by the Government of India and national and international funding agencies. Just to give you a very pertinent a highlight of our center, which is very much relevant to Dr. Nayak's talk today. CODM at IIT Roorkee has developed the earthquake early warning system for North India. Specifically in this project, around 165 earthquake early warning sensors have been installed in Garhwal and Kumaon region of Uttarakhand. And this has been working for almost now 2 to 3 years. And it has been funded by the State Disaster Management Authority, Government of India, Uttarakhand. Along with it, the other research projects which we have been focusing from the center has been on the blue-green infrastructure, which is to develop the natural-based technical approach for urban flood resilience. There are other research projects which have been focusing on the impact of air pollution, climate change on glaciers of Hindu Kush Himalayan region. We have not only the science and engineering side, we have been working with the management team, our faculty from the management department, knowledge management of social media data for disaster management. We recently have developed a decision support system for this knowledge management. Along with it, there are other application research have been going on in terms of remote sensing and GIS application for urban monitoring and slow estimation, as well as from the structural side, we have been working on the concrete mixes and the other and their effect on the forest fires. So these are very few to name the few research and highlights of a center. With this very brief overview of our center, I, on the behalf of CODM faculty colleagues and students, welcome you all. With this, I'll give it to Professor Lakra. Thank you.
Much thanks to Professor Singh for sharing with us about the center. IIT Roorkee has been organizing the Endowed Lecture series in each department and centers named after the iconic national figures who are known for their contribution in the discipline related to the department and the centers. May I now request our Director, Professor Ajit Chaturvedi, sir, to extend brief remark on the Endowed Lecture series. Over to you, sir.
Thank you, Professor Lakra. I'm indeed delighted to be part of this second edition of Professor Jay Krishna Memorial Lecture. As we all know, the inaugural lecture was delivered by none other than Dr. P.K. Mishra, who has worked in the area of disaster for such a long time and is a very well-known, respected figure. I'm indeed very happy that this time, carrying forward the tradition, we have somebody as eminent as Dr. Sailesh Nayak to deliver the second edition of the lecture, carrying forward this wonderful tradition. I wish the lecture would have been conducted physically in the campus, but owing to the very unusual situation for the last 18 months, I'm happy that at least we are able to organize the online lecture and we'll be able to hear Dr. Nayak on this important topic related to triggered earthquakes. As we all know, our institute is going to celebrate its 175th year starting from 25th of November. And no wonder we are proud to have a very long lineage of luminaries across departments in Thompson College of Civil Engineering or University of Roorkee and later IIT Roorkee. And the list is we are proud to say that the list is really very long. Professor Jay Krishna, Professor A.N. Khosla, Professor Bharat Singh, Professor O.D. Thapar, Professor A.K. Kamal, Professor Shankar Lal, Professor A.S. Arya, Professor W.U. Malik, Professor Mithal, Professor Khatri, and so many of them have made a mark at the global stage in their respective domains. That we believe that using their names, we can not only inspire the current generation, not only we can pay respect to the people who have built this great institution. It is their work that is being carried forward by all of us, but it is also possible to get very distinguished speakers to accept this invitation and visit the campus by organizing these lecture series. So I'm happy that almost all the departments have come forward and they are organizing this. In fact, chemical department probably has already organized now 4 lectures, 4 annual lectures have been held, and they did in honor of their founder head, Professor what was his name, Professor? I'm forgetting the name. So in honor of it just slipped from my mind. I'm very happy that now we are here to listen to Professor Shailesh Nayak, and without letting the audience wait for long, I would like to conclude here, and we all look forward to hearing to Dr. Nayak. Thank you.
Thank you so much, sir. Thank you for sharing your insight and the plans and vision we have through these endowed lecture series. So we really cherish your encouragement in this direction. Before moving forward, we will spend a few minutes to learn about Professor Jay Krishna. Professor J. Krishna is known as father of the Indian Earthquake Engineering Program for his pioneering work in the subject area. He was truly considered as an icon amongst engineers whose contributions covered a wide spectrum of subjects and concerns related to academics, research and development, and the profession. He, in 1932, entered Thomson College, Roorkee, later known as University of Roorkee and now IIT Roorkee, as a bachelor student. As he aspired to become an academician, he immediately took the opportunity in 1939 to join as the faculty member in the Department of Civil Engineering at Thomson College. At the University of Roorkee, Dr. J. Krishna rose to the rank of professor in 1960, and in 1971, he was appointed the vice chancellor, thus becoming the first professor of the institute to be elevated to that high office. In 1948, he published 2 volumes of a book on reinforced concrete with his former student and colleague, Dr. O.P. Jain. The book, being the first by Indian authors, became a Bible for the civil engineers. He obtained his doctoral degree from University of London in 1954, and he attained it in less than 2 years, which was rather uncommon. He was first in India to introduce courses in soil mechanics in 1948, in structural dynamics in 1958. He endeavored to envision new directions of thrust in engineering, which would be required by the nation in its development. He was responsible in encouraging various programs. So some of them we see here in IIT Roorkee, various departments and centers. He also worked a lot with younger colleagues. He mentored them and supported them, and some of them became stalwarts themselves, such as Dr. O.P. Jain in structural design, Dr. A.S. Arya in earthquake engineering, Professor Bharat Singh in water resources. Over his long career, he won many prizes and awards from national and international organizations. For his meritorious services to the nation, he was conferred Padma Bhushan by President of India in 1972. He has several important national and international assignments in various capacities. In 2008, he was voted posthumously as one of the 12 legends of earthquake engineering at the 14th World Conference in Earthquake Engineering held at Beijing. Thus, as we may perceive from above, Professor J. Krishna was a mentor to generations of engineers and epitomized the human spirit of inquiry and devotion to academic pursuit. So essential for the development of knowledge. His life and work will be an inspiration to future generation of engineers in India. As Professor Chaturvedi already mentioned, the first J. Krishna Memorial Lecture was delivered by Dr. P.K. Mishra, Principal Secretary of Prime Minister of India and 2019 Sasakawa Laureate. We also witnessed presence of Ms. Mami Mizotori, head UNDRR, which brought the global focus on the event. The Center of Excellence in Disaster Mitigation and Management at IIT Roorkee organized this JKML series, acknowledging its responsibility towards resilient society. So remembering the professional giant, Professor J. Krishna, we host today's second lecture in the series. May I now request Professor T.C. Ashwini Kumar to introduce our esteemed guest speaker, Dr. Shailesh Naik, and open the talk and also facilitate the question and answer. The questions, this particularly for the audience, may be please texted on the chat box. Over to you, Professor Ashwin Kumar. Thank you.
Good afternoon, everyone. I consider it a great honor to introduce our speaker, Dr. Shailesh Naik, for the second Professor J. Krishna Memorial Lecture. Dr. Shailesh Naik is currently the Director of the National Institute of Advanced Studies, Bengaluru, Chancellor of the Terry School of Advanced Studies, Delhi. He was Distinguished Scientist in the Ministry of Earth Science and President International Geological Congress during 2015 to 2017. He was the Secretary, Ministry of Earth Science, Government of India from 2008 to 2015 and provided leadership for programs related to Earth system sciences. He has been credited with launching many research programs related to monsoon, air-sea interaction, changing water cycle, atmospheric chemistry, coastal vulnerability, climate services, polar science, etc. He has also chaired National Committee on SCAR from 2016 to 19. He had set up the state-of-the-art tsunami warning system for the Indian Ocean in 2007 in just 2 years' time to provide tsunami advisories to the Indian Ocean rim countries. He is also fellow of the Indian Academy of Sciences, Bengaluru, the Indian National Science Academy, New Delhi, the National Academy of Sciences, India, the International Society of Photogrammetry and Remote Sensing, and academician of the International Academy of Astronautics. He was conferred the prestigious ISC Vikram Sarabhai Memorial Award in 2012, Bhaskara Award in 2009 for his outstanding contribution in remote sensing and GIS. Sir, it is truly an honor to have you with us at the Center of Excellence in Disaster Mitigation and Management at IIT Roorkee. And before along with that, I want to now humbly request you to share your knowledge on the topic for today's lecture. The stage is all yours, sir. And I also take this opportunity before you begin, sir, to welcome R.K. Bhandari, sir, also for this lecture, sir. We are privileged to have him also along with us. Sir, the digital stage is all yours now.
Thank you very much, Professor Ashwini Kumar. First of all, I'm extremely grateful to Professor Chaturvedi and Professor Sumit Sen to invite me to deliver this very prestigious Professor J. Krishna Memorial Lecture. I have never an occasion to meet him, but I learned a lot about him through Professor R.S. Chaturvedi. And the reason was when I started my career, I was working in the Narmada Sardar Sarovar project. And Professor J. Krishna, Professor Srivastava, and Professor Chaturvedi were consultant for that project. And we used to do, of course, mostly on the engineering geology side, but Professor Chaturvedi always used to speak about very high about him, and I learned about him from Professor Chaturvedi. So it's really great privilege to speak on his memory, and that is why I thought we'll speak on the earthquake, which is, as we know, he was a doyen of earthquake engineering. Not only India, but is respected throughout the world. And many of those things which he has set up, we are getting the fruits from what he has sown the seeds at during those times. As we know that earthquake as such are one of the major hazards, and we don't have much of the information today. And I was very happy to note that the early warning system, which has been now set up, which at least gives some 60-70 seconds lead time before earthquake really strikes. So our emphasis on earthquake the last couple of decades has been quite substantial in India as well as on the world over. We also know that apart from earthquake, there are many other hazards, and I was very happy to learn that your department is looking very important topics, urban flooding, air pollution, and many others which Professor Sumit Sen said. And many of these hazards, as we know, are becoming more intense or increase in the frequency because of various anthropogenic activities. And we know that now the in the world over, the triggered earthquake, the earthquake which are happening because of the anthropogenic activity is becoming quite serious, and a lot of attention is being paid to such earthquakes. Of course, we know that the earthquake essentially represents when the elastic strain energy is released in form of a seismic wave earthquake occurs. But there are some of the anthropogenic activities which also release pre-existing stress of tectonic origin. Maybe this could be artificial water reservoirs, or it could be underground mining, large underground mining. We know fracking of hydrocarbons in Pennsylvania. There are many small earthquakes are taking place because of the hydrofracking for the hydrocarbons. Underground explosions, including nuclear explosions. Most nuclear explosions you can record on the seismograph, and you can estimate magnitude at many others. Petroleum exploration also. Yes. So these are some of the activities which has been triggering earthquake, which may not be very large, which may be maybe 5, 4, or 3, 6 kind of a magnitude, but it does create certain issues in the minds of people. So it has a lot of societal impact, and it is necessary for us to understand how they are happening, what they are, and whether we would be able to model those things. Now, one of the largest earthquake, which is most people believe, there are some still do not consider as Koyna earthquake was result of the reservoir. This is happened in 1967. It was about 6.7. And there are several other such earthquakes have been reported, almost 120 all over the world. Of course, none of them were as serious as Koyna. Now, these earthquakes, it has been found that they are related to loading and unloading of the reservoir, or the highest water level reached, or how long this highest water level is retained, what kind of a port pressure. So there are many other reasons people have studied and given. And by and large, the role of individual triggers has been fairly well understood. Now, that is why we thought that the Koyna, which was a very major earthquake almost 50 years back, and it continues to be active even today, we need to study this aspect, that how this reservoir triggered seismicity, whether we can model them and what we can do this. So this idea started formulating, especially, I must say that Dr. Harsh Gupta, who has been studying this earthquake for quite some time, was the person who initiated this idea. Now, why Koyna be one of the best sites, not only in India, but all throughout the world? The most important reason that the very large earthquake took place in 1967. After that, there are more than 200 earthquakes which are of magnitude 4 and thousands of small earthquakes still. One earthquake of magnitude 4 happened 4th June 2017. Why this is I have written specifically, I should come back to later. This is the time when we were doing the drilling actually. And we have seen from you can see on the figure, that it is very closely related to the loading and unloading cycles. And after some time, the Varna reservoir also came up, and they also introduced the seismicity. The other important aspect that this zone is a very small zone, about 30 kilometer by 20 kilometer, and depth is about 10 kilometers. All earthquakes are occurring in this very small region. So there is no other than possibly these two reservoirs which are inducing this earthquake. And that is why this site is a very critical for 2-3 reasons. One, it is a very shallow and in a very small area. So it would be possible to plan an experiment where we can really measure all the properties which is required to model RTS. And that is why this is considered as a lighthouse project of Inter Council of Drilling. So this site was chosen from that angle as an initial. Now, what all we need to do for this? The first was, of course, we need to understand the mechanism of earthquake and the model, the reservoir-triggered seismicity. So we thought that we will drill a bore well, maybe up to 7, 8, 9 kilometers at appropriate location, and characterize all the parameters which is required for modeling the seismicity, triggered seismicity. So there are many things which we need to do. We need to have a complete fault geometry. So we need to set up fault zone observatory, the physical properties of rocks, how it is changing before, during, and after the earthquakes, what is the hydrogeology, what kind of fluid or gas is emitting and what is its composition, what could be the temperature and heat flow, kind of stress which is there, and probe pressure. So there is many parameters which is required to be measured, and this is what we thought that this project should be undertaken. Now this is a very large project and may run for a couple of decades. So there was a large scale consultations both nationally and internationally. We first signed an MOU with the International Continental Scientific Drilling Program, ICTP, which is stationed in Germany. And we hold a major workshop where a lot of delegates from outside India came and discussed variety of aspects on geology, geophysical, all kinds of things were discussed. And we thought that it would be necessary to characterize the site and where we should be drilling. And so we discussed that the preparatory phase, we should conduct all geological, geophysical, and shallow drills. So once we get this, then we can go to the next drilling. Based on this discussion and many others, Government of India approved this program, scientific drilling, at a 400 crore rupees. So very major program was planned. One of the very large experiment to understand the basic fundamental was agreed by the Government of India. Now this had three major objectives. One, we should set up a deep borehole observatory. As I told you, that to measure various in situ properties of pressure, porosity, permeability, temperature in the fault zone before, during, and after the earthquake. This is the most important aspect, which we cannot do from the surface. We will have to drill, go to that area where the earthquake is occurring and measure this. Now, to support this, we need to have a research laboratory to conduct the drilling, the investigation, the various core analysis, and a lot of other studies. And third is mechanism of faulting and the physics of earthquake, and what is the realistic seismic hazard in this area. So these were the three main objectives with which this was started. Now, there was a lot of information was available. The one which is very important immediately after the earthquake, Geological Survey of India has carried out very detailed mapping and mapped this surface rupture zone, which comprises of various fractures, fissures, the cracks and several things, and very well mapped in this. And this is also a strike slip fault on towards the Koyna side and maybe a normal in the Varna side. Now, at that time also, the lot of soil helium data was collected, and they found that the anomalies, helium anomalies along this Donichawadi fault. This fault is active even today. And in the last 50 years, there are several earthquakes occurred in this particular fault zone. So this was the known information. So idea was that we should drill somewhere where we can cut through this Donichawadi fault. So though the surface expressions were known, it was not known how at depth it is. So that was the one first major task. So the overall experimental plan which was made had a 3-phase. First, the preparatory phase, the second, the pilot borehole, and then ultimately the deep bore. So in the pilot preparatory phase, we drilled 9 shallow boreholes, which is about maximum up to 1.5 kilometer. And then variety of other studies were done. A lot of cores and all this taken. The second, based on this study, we will decide the site for the pilot borehole, and based on the information what we gain or knowledge which we gain from pilot borehole, we will drill the deep borehole, which may go up to 7 kilometers, but not necessarily vertical, it may be inclined. So this was the original plan, and the preparatory phase is already completed. The large amount of work has been done in this region. The 9 boreholes, the geophysical, logging, heat flow, geothermal, magnetotelemetry, gravity data, LIDAR, geology. So all this information was collected as a preliminary. There is large amount of information which has come up in this region. I will not go into the details of all this, but there is a lot of information available on each of these topics. Now, some of the very important outcome of the preparatory work. The first time we came to know that the Deccan basalt total thickness is 1251 meters. There are 46 different lava flows. So this information came for the first time because we drilled right up to the granite basement. So this, the very important information came. We also learned about the basement granitoids, which is granite gneiss, granite, pegmatite gneiss. All this were first time we came to know. And very important thing which we know, that between the Deccan basalt directly rest over the granite gneiss. So there was a lot of speculation or hypothesis that there may be a sedimentaries in between the granite and the Deccan basalt, but we didn't find in any of this area any evidence of the sedimentary rocks. So this was also a very new information. One of the most interesting thing came out is the topography of the basement. There is hardly any undulations. It's about whatever undulations are less than 100 meters. Now this is still, I'm not able to understand why so low undulations where it remained exposed for a very, very long time. So this is another area, this information, and we also could look at fault fractures which are associated with the system. So the preliminary work gave a pretty good idea that what is in this region and allowed us to choose the site based on this information. Now, some of this cores, there are actually 10-kilometer long cores. It's a large amount of cores, which is for Deccan basalt and granite available at the Karan. Could be studied for a variety of purposes. We could see the granular flow, the slicken sites, injected veins, pseudotachylite shattering, all the evidence of faulting in this region. And this is very well documented, and there are still large amount of cores yet to be analyzed, but the analysis up to now has done that this become very clear. Also, in the microscopic analysis, also the same information about the fault breccia, pseudotachylite, and all that become very clear. So we were very pretty sure that what we are trying to locate, we are very close to it. The other study which was done is to find what is the strength of this rock, because that will depend on what kind of earthquake can take place. So in laboratory, the strength of the granite cores were tested. And this is the first time probably in the rock strength has been tested of this region. And it was found that the rocks break around almost north-south fractures, which is quite different than the pre-existing fractures, which is you can see in A and B, and what it breaks is around C. And also when we compared the strength with the other similar type of rocks throughout the world, we found that this has a very low strength compared to the other rocks in similar time. So this also explains that probably of the low magnitude earthquakes have reduced the strength of this. The many such local weak zones, which was found, also gave an indication that we are in proximity of a major fault zone. So all this information was collated and this what we found is the basic properties of this. The first is the temperature. At 1.5, it was only about 56 degrees. This was extremely heartening because that means even if you go up to deep, up to 10 kilometers, the temperature would be around 80 and 130 to 150 degree up to 3 to 6 kilometers. Because when you want to drill, if the temperature is very high, it would end up in many other issues. So we would need to know up to what level we can go and what would be the likely temperature. As I told you, the weak plains, which is other direction than the pre-existing cleavage plains, clearly indicated ongoing seismic activity. A lot of secondary mineralization, which I showed you, also indicated that the percolation of water, the fault fluid zone has a very low conductivity. The seismicity always found to be associated with density or velocity anomalies. And as I told you, the rock strength is weakened by successive seismic activities. So it may not be sufficient strength, so the stress will not be accumulated and it may not produce very large earthquakes. So that's why we have been seeing many earthquakes, but not larger than about 4 or 4.5. So after this, we again had a large consultations and all the initial results about the structure, geochemistry, geochronology, paleomagnetism, hydrology, and mechanical thermal properties, they were discussed. We followed with the international workshop, and then we thought that it would be better to drill a pilot borehole up to 3 kilometers and then deep drilling up to 7 kilometers. So this, after about 3 years of intense work, we came into conclusion. And This pilot boreholes drilling was a major challenge because we never had such a large well drilled in such terrain. ONGC has been drilling, but mostly in sedimentaries, and this was the first time. So support of ONGC for this was extremely useful, and they provided a lot of input into the drilling. And we took a decision that we will not take any outside help for the drilling, we will do ourselves. And a lot of expertise got developed in this drilling. And we drilled up to 3 kilometer absolute vertical within 3 degrees, which is permissible, extremely fast. About in 6 months' time, we drilled that, and which passed through about 1250 meters of a basalt and about 1760 meters of a basement rock. So we had a lot of experiment on the how to drill, and it was hybrid drilling, air hammer, and the mud rotary drilling. We did not collect cores as much as required in the Deccan basalt because we had already large amount of cores. And because of the various techniques which were developed, we saved a lot of time and the money as well. So this was a really good experience that we did, and we became very confident that we would be able to drill up to 7 kilometers on our own. Now, when this borehole, there were many issues. The one issue is why this is very unique. You know, many of you may be knowing that US also drilled a similar borehole in San Andreas to understand the earthquake physics of the earthquake. But unfortunately, where they drilled, the earthquake has not taken place. The Koyna is a site where we have been seeing that earthquake is taking. Actually, the earthquake did took place when we were drilling on 4th June, as I told you earlier. And we could see some of the things while the drilling was on. So this is something which is very unique kind of an experience. I will show you some of the results of this pilot borehole. Now this is the, we are pretty sure that it was in proximity of the Donichawadi fault. A lot of cuttings were taken, the gas samples, geophysical, electrical, acoustic images. So all this were, a lot of experiments were done while doing this. And we could see very clearly where is fault zone between 2100 and 3000 meter depth. So I will show you some of, but this is the, how the well configuration and the general lithology of the, what we call as a Koyna fault zone 1. KFD1. Now the cores which were obtained have been very well studied. They were all marked, photographed, and then curated in a lab. The drilling chips all also have been collected. So a lot of information and the data is still to be analyzed, but there is large amount of data, and since there will be many students and all those who may be interested can definitely contact them to take up some studies in this area. Now this is the some of the results which we can see on the electrical resistivity and acoustic. So where you can see some of the breakouts. Now this is basically happens when the stress around the borehole overcomes the compressive strength of the rock. And this is occurs always in the direction of a minimum horizontal stress. So one is this breakouts, which we could see very clearly on both the acoustic image and the electrical resistivity. Similarly, some of the drilling induced tensile fractures, also were seen breakouts, and this were found to be aligning with the maximum and minimum horizontal stress. It can be seen very clearly, and many specific zones below 2100, you can see with the gray, some of the zones have been marked. These zones are basically weak zones, and that is where our interest lies. Now, this basically the orientation was found as the north 9 degree west plus minus 17 degree. This is where we found with the earlier also I showed you that is almost north-south where it breaks. So this is very consistent with the original orientation also. And whatever we have been seeing, it definitely we were certain that we have passed through a local fault zones, and this also proved that this is a strike slip to normal faulting environment. So this pilot borehole drilling provided a lot of information and confirmed many of the things which is very critical. There was also online gas monitoring system was set up and the information collected and analyzed, and you can see some of the peaks of methane, hydrogen, helium, carbon dioxide. So a lot of data has been collected, and I will show you how they have been correlated with the other data. So this is the major 7 zones which have been found between after 2100, and you can see that they match very well with the helium, anomalous helium fracture zones as well. So these zones were confirmed, and these are the major outcome of the drilling the pilot boreholes. Because we wanted to make sure that when you drill, we pass through the fault zone, then only we would be able to measure various properties which is required. A lot of integration of geophysical, geochemical also has been done, and this also further confirmed that the whatever I told you that after 2000 meter, there are fault zones which are characterized by very high fracture density, and we had gone through many fault zones. So basically the conclusion was that we were very close to Donichawadi fault zone or its subsidiaries. So basically the idea that we should be in very close proximity of this fault has been achieved. Sorry, this 5 is wrong, it's 7 zones. So these are some of the things which has been identified. The important thing which I would like to stress that the strain and straight analysis which is been done has been shown that this is the variability in the deformation is because of the frequent earthquakes. And the rock strength of this rock has been modified by continuous seismic activities. And it also says that the rocks are not strong enough to produce large earthquakes. So this is very important aspect that there won't be a large earthquake as happened earlier in 1967. The temperature at 6 to 7 will be around 130 to 150 degree, which would be quite manageable for the drilling. And so this is where we are. We have to yet to drill the 7-kilometer deep borehole. But some of the other aspect, the assessment of the hazard. Now, a lot of studies have been done in this, and it was found that the Koyna and Warna, these are the 2 separate seismic zones, while the strain accumulation in Koyna is almost 11 times larger than the Varna. The reason is that the Koyna releases only part of the energy which is accumulated every year, about 20%, while the Varna releases almost all the energy. The basic idea that means that the Koyna, the activity is likely to continue for more time by Varna. This is very important because once you drill the borehole about 7 kilometers and if seismic activity doesn't take place, then the whole experiment can fail. So this was very essential for us to find out whether how long the earthquake activity would be continuing. So it is possible that the Koyna there would be enough strength maximum which can generate earthquake of 5.8. So if all the energy is released in a single event. So this is very important aspect which also provided us the assessment of likely hazard in this very small zone. Now some efforts have been tried to model the reservoir-triggered seismicity. Essentially, in this case, the core pressure has been taken and this is at a very preliminary stage. The different pressure has been taken and it was found that permeability should be something around 10 raised to minus 15 per meter square to 10 raised to minus 14 per meter square, where it can induce a seismic activity up to 10 kilometers. Of course, all the parameters, there are a lot of assumptions in this, but now we will be measuring all the parameters which is required for RTS actually, and then we will further carry out this model. Now, the further work which we need to do is we have to put a borehole seismometer for long-term monitoring, the analysis of the core samples for understanding variety of lithology, geochemistry, physical property, all that has to be done. And then deep drilling at the same time, after drilling, set up the observatory to study the changes in the physical, mechanical, and chemical properties. And this is, I think, the most important aspect which we would be addressing. And probably first time in the world, anybody would be able to do this kind of a measurements. So once we have all this, we would be able to understand the earthquake mechanism. And overall, when the large engineering projects happen, there was always an issue that it can be induced earthquake. We would be able to advise based on this kind of our understanding whether earthquake can damage the structure or this either. So these are very draft kind of a plan for the what kind of a measurements which we would plan, but there is a lot of discussion going on how and well we would be doing. But this is one, these are the measurements which is required for understanding the reservoir-triggered seismicity as well as the mechanics of the fault. See, this is the main part, but it generated a lot of other studies, and I won't go into the details of this, but these are the areas on tecton volcanism, paleomagnetism, thermal structure, stress in lithosphere, geothermal potential, the records of the climate change over a long period of time, and very interesting on geomicrobiology. The IIT Kharagpur has done fantastic work on kind of the planktons were there and how it can be studied. So there are many other new topics which could be studied. So this program not only generated a lot of information about the reservoir-triggered seismicity, but also provided a lot of other information in the variety of field. And also we introduced a new field on a borehole geophysics, a deep borehole geophysics, to understand variety of other topics also in the country. This is now coming up, the laboratory, the buildings and the core repository. You can see how big it is. And this is now likely to be started in a couple of months, hopefully. And these are the various groups who have been working on this laboratory. And I must profusely thank Dr. Sukanta Roy, providing a lot of input on this my presentation. And of course, Dr. Harsh Gupta, who was initiated this and basically sown the seeds of this project. Dr. Bansal, who was main behind to work out a lot of background work on this project. And of course, the last 10 years, NGRI, the directors and scientists have been extremely supportive in this. So with this few remarks, I would like to end my lecture. I would be very happy to answer any question. This is the drilling site, as you can see. Thank you. Thank you.
Thank you very much, sir, for this wonderful presentation. Hats off to you and your team, and for the agency who approved this work to go for such an ambitious work, I mean, and significant work, sir. So we will now move on to the question and answer session. I request from the panelist members, anyone would like to ask a question? Anyone?
Yeah. May I come in?
Yes, sir. Yes, sir. Yes, sir.
Just a very Dr. Nayak, basically I do a lot of field hydrology work. So I'm a hydrologist by training. So just a quick thought of yours, and you have been there in Ministry of Earth Science. It's not because your career was also like on a field work or field studies. So how do you take what's your take towards the field studies? Like sometimes in our new generation, for the new students as well as the faculty also, and sometimes the funding agency, they are more looking for the quick results and quick modeling type of results. What do you suggest in that area?
No, I think there is no way we can avoid a field study. And you had raised very pertinent question, and that is why I thought I would take up this case study, because it has already passed 8 years and another 8 years probably will go. We had thought that it would take about 2 decades to come up with this. And I think that kind of projects, unless and until you take up a large projects to understand the fundamentals, and many of these fundamentals you need a right there, go characterize and get the felt data to model it. See why we are not able to model earthquake? Because all measurements are done from the surface. Why we are able to do forecast of cyclone very well? Because we are able to see how the cyclone generate, the hazard generate processes. We are able to see. That's why we are able to model it and forecast it. Earthquake, we are measuring everything on the surface. So signal may come, but it gets modified, and exactly we don't know how it is getting modified because we don't have exact information about our lithosphere as well. So I think the field studies are very central, and I agree with you. Some of the young generation, they would like to work more on the computer and all. I'm not saying it is not important. The simulations, in this also we have done a lot of simulations. You know, these are very, very critical aspects. But there are certain things like if we want to measure what exactly happens before, after, and during earthquake, we will have to go to that place where earthquake is happening and measure it. Unless you do that, I don't think we would be able to model it. So I fully support your idea, and actually, I think in most cases you may reduce the amount of fieldwork by, say, satellites and many other observations. But I myself have been using satellites for all my life. But I think the going to the field is very critical to get overall idea, to get the feel. to understand the entire area into that sense. So it's very critical.
Thank you, Dr. Naik. Maybe just one quick add-on to the question. It is again towards my center students, research scholars, and new faculty generation. What areas could you suggest to our students? Like some areas you might have thought, okay, this areas could be something which needs to be still explored. Maybe just have one or two thoughts on.
I think there are two things in my view. Of course, I am not sure whether it is a. One is we need to understand water. I mean, I'm not saying because you are hydrologists, I was not knowing before that, but I have made a suggestion that there should be a water census. That the variability is quite large in our country, and depending, we should be able to simulate that depending upon the rainfall, what would be likely availability of the water in a particular region as an actual places. There are a lot of information available now. Grace, a lot of people have shown that how it can be done. And also the Central Groundwater Board does a lot of monitoring, but we don't have actual census of the water. I think if we can, there may be issues. I'm not saying that tomorrow we decide it will happen, but I think it is doable. I don't think it is not doable. And specifically in the water census, I would like to stress more on the shallow groundwater table. The reason is that the shallow groundwater table, two important functions. One, it maintains the basewater flow, and second, it supports the ecosystem, including crops and everything. Now, today we don't have, I mean, I may be wrong, but I don't think we have a good handle on a shallow groundwater table. We always worry about groundwater table. I mean, we have been told also that how to measure this, that, but what about shallow groundwater table? Whether there is any changes occurring and how it is likely to behave with the changing rainfall pattern. The reason is that what is happening is now we are getting more extreme heavy events and a low number of low and moderate events. So you know better than me that the percolation has drastically reduced and the runoff has increased. Now this we have to model somehow, and localized way of understanding has to be built. And if we can do this, I think it would be extremely useful. Of course, there is other areas which I think equally critical is about energy, but especially energy which is in form of a gas hydrates. There's a lot of work done by NGRI and NIO, NIOT, and ONGC, of course, is drilled two major wells, 1.5 kilometer well in the Bay of Bengal they have drilled. Now, this information which is deep drilling which is available is not available to us also. Actually, I think those information which we are doing on a deep drilling should be made available to student teachers for this. And as I tried my level best, I was not successful, I must admit, but I think we should keep pressure on, because this is where my feeling is that the deep scientific drilling in our country is an area which is not got sufficient attention. And we need to stress on that aspects. And we have already proposed another 5 major boreholes if government agrees, or along the Indian subcontinent. So I think we need to, both in the sea and on land, we will have to take up this to understand many of the mystery, or if you can want to get some basic knowledge, I think we will have to do that.
Thank you, Dr. Naik.
Thank you, sir. Anyone else would like to ask a question from the panelists?
Bandari, sir.
Bandari, sir, would you like to say something, sir? Sir, you're on mute, sir.
Am I audible now?
Yes, sir. Yes, sir.
First of all, Dr. Nayak, that was a very brilliant speech. And I think you have given insights which would keep our young engineers busy with what Dr. Krishna hold dear. I get to remember this Tehri Dam where his of India advised him to come to Tehri. That was the level of confidence he had in the safety. On the reservoir-induced seismicity, about this Koyna and all that. About Tehri, I would like to really raise a couple of issues, and Russian scientists were also coming in visit the place. In the rim area, the landslide activity was not much. That was one. Secondly, over the period of years, the rapid pace of construction has thrown so much of muck in the river, and multi-hazard concept, which was not at that time at the center stage, is now one of the very serious matters. The studies done on the reservoir levels, which were in 2012, 2013, and thereafter, they are alarming. I try to raise this issue with a number of colleagues in CWC and other places, and I still don't have the answer to whether any serious forecasting is being done on the scenarios that might develop in Tehri. So first question is this, whether it is being done, who are the people who are doing it, and if we would like to really ask the Center of Excellence Disaster Management at IIT Roorkee. They are so close to that place, and it's such a serious issue for Uttarakhand, which is also related to multi-hazard concept and all that, and therefore any piece of it. Thank you.
Thank you, Bandari Sahab, and Namaskar. After a long time, I have been seeing you almost 2 years now, so it is good. Yeah, actually, there are 2-3 issues in Tehri. Whatever I know about Tehri is it has not induced any seismicity after the impoundment of reservoir has taken place. But I must also admit that I have not had looked at the data which is available around Tehri. Of course, I read about those things. What I learned is that there are certain changes happening in the Tehri, especially as you rightly mentioned about the landslides, and also, but that could be because of many other reasons, and because landslides do occur because of the seismic tremors, but also can occur because of the heavy moisture. And I don't have the data exactly to comment on this. Only thing I can comment is that as far as normally if any change occurs because of the anthropogenic activities, if it has introduced any additional seismicity, the earthquake would have already occurred. The reservoir is quite old now. So it would have occurred like the Koyna, it happened within 4-5 years. So similar thing would have occurred here as well. But I would agree with you that detailed observations on the changes in the water level, also the GPS, also I would suggest the SAR interferometry, whether how the strain, whether developing, is there any changes occurring in this region or not, that has to be monitored. I'm not sure whether anybody doing or not, because after I left government like 5-6 years back, I don't have the access to the information, or nor I know whether anybody is working on that or not.
Thank you, sir. A few questions in the chat box, sir. One is related to us, the negative effects of creating dams across the river. So the question is, do dams, can be perceived as a negative, more negative than the positive, and to the extreme effect that whether it affects the orbital rotation of the Earth. The question is regarding that, sir. So.
No, we have to see from a quite different angle, and anything man does affects the environment. There is no doubt about it. But if you see the dams which has been constructed in India, and if you take example of a Bhakra Nangal, today we are sufficient in food because of the irrigation provided by Bhakra Nangal. So we can't say that it has a negative effect. It may have certain negative effect, but it has also a lot of positive effects. So each dam, like I know about the Sardar Sarovar in Gujarat, there was no water, drinking water, even in North Gujarat and Saurashtra. Now, after this dam has come, the water is available for drinking also, and many cities are being provided water. The Chennai, the water comes from the Krishna. Bangalore, water comes from the Krishna Reservoir. So, if we do not the requirement, our requirement of because of the high population, the food requirement, the drinking water requirement, and many such things are require us to do this. Many people also argue that we can have small dams and check dams and all that, but when you want to transfer the water from one area to the other area, or one basin to the other basin, you cannot do with the small dams. Check dams. You have to see, like Bhakra Nangal water reaches up to Rajasthan, Sardar Sarovar water reaches up to Rajasthan, Krishna water reaches up to Tamil Nadu. So it goes across. So when you want to transfer large amount of water, you will need large dams. And we should use our knowledge to minimize the likely damage which can occur. That part I agree. Many times we don't do, now we are doing environmental assessment, but recently we have also started the assessment of the social aspects, which is not done earlier. We would be doing first time for the culture project, the social aspect. I think we need to understand all aspects, the scientific aspect, the social aspect, and the aspects of the policy of the government. All these three we need to put together, and there are always a trade-off. I won't say that if you basically when you construct a dam, you are obstructing the natural flow of a river. So there would be a problems in the downstream, there would be issues. There is no doubt about it. But at the same time, I think we have to also see our requirement and make the balance, and should do the trade-off in such a manner that we do minimum damage to the environment.
Thank you, sir. A question from my end, sir, with respect to dam. Yes, sir, ML Sharma, sir, please. After you, I'll ask.
Thank you, Ashwin. Namaskar, sir.
Namaskar.
Really, it was a great, very great, bold decision just before 1 decade. I remember these things because I was actively participating in all DST meetings when you were leading that. So it was really one of the very, very bold decision to go for the deep drilling project. And it has already received a lot of accolade from international scientific fraternity. And Dr. Bhandari has also raised the Tiri Dam issue, which was also one of the boldest decisions at that time, because these decisions, they are really helpful for the society and the science. So we are anxiously waiting for these results from this experiment, because we will be the one who will be using the most useful results from this, because we are monitoring this Tiri Dam for last more than 3 decades and working on triggered seismicity, but somehow we have not got any positive response from the seismicity and the level of the reservoir. And also because of the different tectonic setup. Here you are having the reverse thrust faulting. So maybe the triggered seismicity may not have so much of effect, which is well known. But we are very anxiously waiting for the results from your experiment, sir, and very closely watching this. So I must congratulate you and your team for this, and let us hope that we go in the right direction and go for very, very important results which may come out of this experiment. Thank you, sir. Thank you.
Thank you. Thank you, Sharmaji. Thank you very much.
Thank you, sir. One question, sir, from my end, in terms of the way we are designing, let's say, a dam structure or a nuclear power plant or a thermal power plant, we are not considering a deep exploration kind of a thing. We are mostly limited to 30 meters of borehole exploration kind of for buildings and all that we are doing. So this deep exploration that the team is conducting right now, how is it going to affect what we are doing right now in the short duration, whether it is related to the reservoir induced kind of seismic kind of thing, and for a long duration effect on or demand on the different structures, let it be dams, nuclear power plant, and buildings?
If I have understood your question correctly, the idea is that first time we have been done such a deep borehole, and we will be making measurements, and measurements are being made this. Now, we need a lot of measurements and repetitive measurements when actually earthquake occurs. And so if in a year there are 5 or 6 earthquakes occurring, we need sufficient number of earthquakes to occur before we can say very conclusively that, okay, this is what likely. I mean, minimum sample which you need is about 30-40 events to make any definite conclusion. So that is why it is taking little longer time. And the other information which we are doing, like 30 meter, which you say maybe specific plant, there the requirement is of that nature. So you don't have to go to, because you are not going to do your foundation at 3 kilometers. You don't need to do that. It will depend on what exactly you want to understand. And depending on that, the depth is decided. So like here also, I mean, today I just tell you within 30-40 minutes, very gist of it. But to decide the depth, to decide the location, there is a lot of data, lot of people have provided their input to finally zeroing on the site. Because once you do drill, and if you can't reach to a fault zone, then the whole experiment fails. So a lot of efforts are being made. All kinds of possible techniques which is available, everything was used before we zeroed in on the site. And the site was pretty good because we are getting all the fault zones, 7 fault zones we have already covered. And once we go up to 7, I think the whole sample data will be extremely good. I don't know whether I have answered your question, because I am not able to understand the actual question why
Sir, I'll add on a small point to that. I would just want to add on in a case like if I'm building a new dam, I mean, the projects that are happening in Uttarakhand and all, if I'm building a new dam in a particular place and I don't have a deep exploration, what difference would be making in terms of the design aspect? Because I work more in the design side. So
no, I think Sharmaji made this point very clear. See, the kind of faulting which is there will decide. This is a thrust faulting, which is not likely to induce any reservoir-induced seismicity. It is mostly the normal faulting. For some cases, like slip also should not. But in this case, we have been seeing this. So that is why you see all the conclusion is a slight slip and normal transition, that kind of thing. So we need to understand the fault geometry very well before we can make a decision like that.
thank you, sir. Yes. Anyone else would like to ask a question? Okay, I think we can close this session. Thank you very much, sir. Now I request Professor Anil to give the vote of thanks.
Thank you very much, Professor Ashwin.
Thank you.
And it is really an honor for me to deliver a vote of thanks on this special occasion of second Jai Krishna Memorial Lecture. So, on behalf of the Center for Excellence in Disaster Mitigation and Management, I sincerely thank Professor Shailesh Nayak for delivering this lecture. Thanks a lot for sharing your knowledge on triggered earthquakes in such a lucid manner. The Institute is really honored to have you as a speaker for Jai Krishna Memorial Lecture Series. I must thank participants who have attended through WebEx platform and YouTube Live. And thanks to the authorities of the Institute for their continuous support in organizing events. And thanks to the students and staff of the center. To name a few, I thank Shivani, Atul, Deepti, Professor Piyush Srivastava, and Shri Tahir. Many thanks to the staff members of Deputy Director Office, especially Shri Rohit, for the assistance related to the publicity and WebEx logistics. And the recording of this lecture will be available in IIT Roorkee YouTube channel. Interested people can go through it whenever they wish to. Again, thanks to each and everyone for making this event a grand success. Thank you.
Thank you. Thank you very much.
The session is closed now. Thank you.
Thank you.
Dr. Nayak, Dr. Gauri, I think Dr. Lakra would like to have a quick photograph, but Dr. Lakra, I think event doesn't allow the attendees to turn on the video. Sorry about that. But I think I request all the panelists.
Request for a picture.
At least the panelists can turn on the videos, please, so that it will become a memory for all of us. Yes, we have. How do we? Just give me. Dr. Lakra, you are doing it?
I'm also trying, yeah.
Okay, I'll also try. Yeah. Dr. Ajanta will take up. 1, 2, 3. 1, 2, 3. Yeah.
Thank you.
Thank you.
Thank you. Thank you so
Thank you,
much.
Dr. Nayak, and thank you everyone for
Thank
joining.
you. Thank you.
And thank you all the students for joining. Thank you, Dr. Bandari, for joining.
Thank you. Thank you.
Thank
Thank
you.
you.
Thank
Thank
you.
you.
Namaskar.
Thank you.
Namaskar.
All right. We'll close.